What's up everyone, it's Bryce from LangChain, and in this video I am extremely excited to announce our newest project, SWE. SWE is an async, cloud-based, open source coding agent. What that means is you connect your GitHub account to SWE, send it a task, and it does the rest. It plans, executes the plan, writes code, runs tests, runs your different scripts, and then reviews the code before putting up a pull request to make sure it's all high-quality code. And when it's done and it determines that everything has been executed properly, it puts up a pull request, which you can then go and review, merge, and then complete the task. As a demo, I'm going to send a new request to my Express.js app where I wanted to add an in-memory data.json store to store my data. I wanted to implement this, write some tests, and then handle all the errors gracefully. I'm going to then send this message to SWE. And as we can see, that brought me to the chat page. It set up the environment. We run all of the SWE tasks in a sandbox in the cloud. This is powered by Daytona. And this allows us to do two things, which you can't do if you're running, say, a local agent. One is run essentially unlimited SWE tasks at the same time. What I do nowadays is I wake up, I plan out what I want to get done in the morning, I create all these different GitHub issues for that, and then I simply kick off SWE tasks for them all at the exact same time. Since SWE connects directly to your GitHub, you simply add a label to the GitHub issue, and that kicks off a new SWE task. It spins up a sandbox in the cloud, clones your repository, checks out a branch, and then starts working on it. The second thing is, since it's in a sandbox, I don't need to worry about any sort of malicious command, say deleting my entire computer, because it's all in a sandbox. Because we don't need to worry about this, we don't have any sort of guardrails around the commands it can execute. It doesn't have access to secrets, so we don't need to worry about it leaking those. So if it wants to execute a shell command that says, delete the entire repository, sure, because it's on its own branch, it's in a sandbox, it's isolated, and this allows SWE to move really quickly because it doesn't need approval from the user when it wants to execute any sort of command. So as we can see, it's running, it's gathering all this information about the repository, viewing different files, running tests, installing dependencies, and as we can see, it's done, so it's going to start generating the actual plan now, and once the plan has been generated, it's going to propose it to me, where I can then go and accept it as is. I can edit individual plans, delete them, or even send a message back to the manager, right? This is the manager on this side, and say, hey, I actually want you to update the plan in this way. So as we can see, it generated this 6-point plan. If I don't like something, I can simply edit it. I can also delete it, or if I'm happy with it, I can hit continue. So I'm going to hit continue. This is then going to kick off a programmer task, and while that runs, I'll tell you a little bit about how we've been using SWE internally. So the first is using SWE to write SWE. If we go to the repository and look at the insights, we can see it's the second biggest contributor to the SWE repository. We use it a lot for writing changes to the front end, updating the actual agent, documentation, and so on. But it's not just SWE. It's also tied as the biggest contributor to the LangGraph open source repository. If you know anything about the LangGraph repository, you know that it's a highly complex repo with many different sub-packages, apps, documentation, highly complex tests, and so on. And it's been being used internally by our team to write lots of LangGraph code, right? As you can see, it's tied with Sydney, who's one of the core maintainers of LangGraph, as the most contributions for this week. Now, if we take a look at an actual example, we can see this PR, which emerged last night. This was an issue that somebody from the community opened and said, hey, there's a problem in OpenAgent platform, can you fix it? I simply added this label to the issue, OpenSWE Max Auto, and that kicked off a new SWE task. It generated a plan, acted on that plan, put up a pull request, very simple, one-line change. It figured out exactly what to do, and in the simplest possible implementation, it fixed that problem for me. Gave me a nice description, linked back to that issue so it would automatically close when I merged the PR, and passed CI. As we can see, only SWE made commits. I didn't have to change this at all. Its very first try worked as is, passed CI every single time, and I simply said thanks, and I merged it. So that's an example of a very simple task that SWE did extremely efficiently. We can now take a look at a much more complex task it did. I wanted to add SWE-bench evaluations to the SWE repository. What I did is I wrote up this detailed plan about what it should do. I gave it links to the actual SWE-bench website because SWE can go and research the web for you. And I said, implement evals for me. As we can see, it was an extremely complex 19-step plan. When it did it successfully, it opened a PR. And if we look at this PR, we'll see 8 files, 2,600 changes, a nice body description, only commits from SWE. I didn't have to do any work for this. All of them passed CI. And at the bottom, we can see everything worked. SWE put up a PR for me. It's ready for me to review and use. And it did it all on its own. And all I had to do was give it this description. So that's how SWE works. Let's go back to this task. We can see it's working on its different tasks right now. as they complete, the plan progress bar up top will update, so we can see number 1 has been completed, number 2 is in progress, and we can even inspect all the different plans which it's going to be working on in the future. Another nice thing about OpenSWE is because we have this manager right here, I can send it a message and say, actually, rename this file to XYZ, or you know what, I've changed my mind on the product spec. And the manager will then go and pass this message along to the programmer or the planner. This is really nice because with a lot of current coding agents that are being used out there, you can't really send it messages and update its task in real time, right? You'd either need to completely kill the agent, pause it, or start a new task. With OpenSWE, that's not the case. You simply send a new message, and our manager will figure out the best way to route it to the planner or the programmer, and the planner or the programmer will then go and pick that up and use it in whatever action it's working on. So that is kind of how OpenSWE works at a high level. We have a lot more features in the UI, like token usage. You can see all the different threads. You can go back and inspect the planner, programmer, and so on. Now, if you want to use this, of course, it's an open source repository. You simply go to LangchainAI/OpenSWE. You can clone this yourself. You can contribute if you want to help improve it. Read the README. We also have documentation for this. So if you go to docs.langchain.com/lab/SWE, and of course, I'll include all of these links in the description, you can read all the docs on how to use OpenSWE, how it works under the hood. You can get a look at the different graphs we use, look at examples you can ask OpenSWE, and then also, if you want to use it yourself, we have a detailed development setup guide so you can fork OpenSWE, use it for your own internal use cases. Now, that leads me to my next point. Why did we build OpenSWE? We wanted OpenSWE for 2 main reasons. The first is because there wasn't really an open source coding agent that had the same level of features and integrations that OpenSWE has out there. So we wanted to build one. And the second was because we want one that's really good at LangGraph. So for the first, there wasn't really any open source coding agent that matched OpenSWE, right? There were local open source coding agents like Codex. You had closed source, fully autonomous coding agents like Devin or even Claude Code, but there wasn't anything where I could connect it to my GitHub account, add a label to the GitHub issue, or invoke the agent through the UI, have it spin up a new sandbox for me, execute all this code in the sandbox, properly plan, executing the plan, review its own code, and put up pull requests. Because there wasn't anything like that, I was forced to use other closed source providers where I didn't know what was going on and I had to just say, take my code base and figure something out. Or I would have to use local coding agents, which didn't work the best for me because I wanted to be able to run many of these tasks in parallel. So we built OpenSWE. The second is writing LangGraph code. We wanted an agent which is really good at writing LangGraph code. Right now, we're working on a version of OpenSWE which is prompted specifically for LangGraph code. But it's not just going to be good at writing LangGraph code. We also want it to be good at writing agent architectures. So this is something where in the LangGraph documentation, we outline many different agentic architectures. And even if modern day coding agents can write LangGraph code, they typically aren't good at writing actual agents themselves. So this is something we're going to be releasing in the next couple weeks, which is essentially OpenSWE LangGraph Engineer. You'll be able to use this to build agentic applications or just agent services for you fully autonomously done by OpenSWE. So that's what OpenSWE is at a high level. I hope you enjoyed this. I hope you enjoy OpenSWE. You can use OpenSWE by going to swe.langchain.com and simply inputting an Anthropic API key. We manage the GitHub app, the agent deployment, the sandbox, everything else for you. You simply need to provide an Anthropic API key and then kick off your OpenSWE task and see it work. You get insights into all the different tokens that it consumes, so it's not going to go and spend all this money on its own and not tell you about it all. As we can see right here, we've used almost 1 million tokens, but we're caching all these tokens with Anthropic. So only 5.7% of the tokens we've sent to it have been uncached, which means that we've been able to save a lot of money. So in this case, we've only spent 62 cents, and $2.22 of that we would have had to pay if we hadn't cached these tokens ahead of time. We can also look at model breakdown and so on. There is just a ton of features in OpenSWE. I'm really excited to see everybody use it and give us feedback so we can help improving this to build the best coding agent for your own tasks.